Let's look at another example using the fundamental theorem of algebra where we have to create a polynomial function. So find an nth degree polynomial with the given conditions. N is 4. So again, this is how Math Excel phrases these questions. That's why I'm writing it like so instead of just saying find a 4th degree polynomial. So we know that if n is 4, it's 4th degree. And if it's 4th degree, it has 4 zeros, right? And then they give you 0, -1, and 3 plus I. We've said a couple of times now, if you cannot have one complex zero. You have to have complex zeros have to come in complex conjugate pairs, which means the zeros are actually 0, -1, 3 plus I, and 3 minus I. So these are our zeros. The zeros can be put into binomials with x, okay? And I'm going to write them out like so, where we're subtracting those values. So watch this one, x minus 3 plus I, okay? And then this other one would be x minus 3 minus I, right? I'm writing that entire, that's one number. I know it's two parts, but it's one number, and that number gets subtracted, right? Both of these have to be subtracted. That's why I'm putting the parentheses around. But we don't have to leave it like this. We can clean all this up. I just like writing it to show that we're always subtracting the zeros from x, okay? So this becomes just x. Here we get x plus 1. Now what I'm going to do here is I'm going to multiply this negative in here, or distribute that negative, and that's going to become x minus 3 minus I. And then we're going to have x minus 3 plus I. Right, when I distribute this negative into this quantity. So I have this big mess, right? And what do we say? We're creating the polynomial. Well, the polynomial gets created by actually multiplying all of these factors together. I'm going to start with these two because that'll be easy, right? X distributed into this quantity is here. Now over here, we got our work cut out for us. Now there is a trick, okay? And I think what I'll do is I'll record a second video, all right, to talk about what this trick could be. For the time being, I think we can just kind of grunt our way through this and put in the work where we're distributing or foiling 3 terms into 3 terms. It's a lot of work, but we're not shy about work around here. So x times x is x squared. X times -3 is -3x, and x times positive I is positive xi, right? I'll even color code this for you. -3 times x is -3x. -3 times -3 is positive 9, and -3 times positive I is -3i. Last but not least, negative I times x is negative xi. Negative I times -3 is positive 3i. And negative I times I is negative I squared. Okay? So we end up with 9 terms in that expansion, right? It's not difficult, it's just work. Don't confuse those things. Now when we look at this, some of these terms are going to cancel, right? The x squared, there is no other x squared term, so that's going to stick around. -3x, do I have any other terms that just have an x, right? We have that. This is ix. This is a complex number. This is a real number, even though it has, so we can't combine these. We can only combine the terms that just have an x. And those are the only terms that just have an x. So I've got a -6x. Now we've got positive xi, and we have negative xi. So what's going to happen with those? They're going to cancel each other out. Okay, let's jump to here. I've got -3i, and I've got positive 3i. So those terms are going to cancel out. The positive 9 that's here, and what's this? What's negative I squared? Right? Well, I squared is -1. So negative I squared is -1, which is a positive 1. So this term right here, even though it's I, it's a power of I, which can be simplified. So this is a positive 1. and we have a positive 9. So that entire sum becomes 10. Okay? Some of these terms canceled. This one could get simplified. I combined everything else that could be combined, and I end up here. All right? Let's continue with our massive expansion here. X squared times x squared is x to the fourth. X squared times negative 6 is negative 6x cubed. X squared times 10 is positive 10x squared. X times x squared is positive x cubed. X times negative 6x is negative 6x squared, and x times 10 is positive 10x, right? So it's not necessarily foiling, it's distributing, but we're making sure we hit all of these terms. We continue by combining like terms. There's a negative 6x cubed and a 1x cubed. That's negative 5x cubed. There's a positive 10x squared and a negative 6x squared. That's positive 4x squared. And then we have this x term here. So here's our function, right? This is what we've created from those zeros. The one thing that we have to look for, though, is this piece at the very end, right? Where we're saying, okay, the value of this function when we plug in the number 1 has to be 30. So let's test that to see if that actually works, right? If I do f of 1, that would mean I'm putting a 1 here, I'm putting a 1 here, I'm putting a 1 wherever there's an x, right? Let's see what we get when we do this. So this is 1 minus 5 plus 4 plus 10. So this f of 1 produces a value. This is supposed to be, I'm going to put a question mark, this is supposed to be 30. Does this equal 30? No, right? If you add all these terms together, you get 10. So we didn't get all the way to 30 when we did f of 1. So in order to get the value of this entire expression to be 30, did this in the previous video, I have to multiply this by 3 to get 30, which means I have to multiply all of this by 3 to get 30, which means I have to multiply all of this by 3 to get 30. And you see where this is headed. The entire function has to be multiplied by 3 in order to end up with a result of 30 when I plug in this number 1. So the final answer is 3x to the fourth minus 15x cubed plus 12x squared plus 30x. This is what we get when we multiply. Sorry if you can't see it, I kind of threw it off the screen here. But this is what we get when we multiply all of the terms in that function by 3. Okay.